Hi friends, my name is Krishna. Today I'm going to walk you through my use case. Uh, the data set data for my use case is provided on Kaggle, um, and my use case is to identify the fruit in the image and classify the image uh, as a certain fruit type, depending upon the fruit it contains. And this data set is provided by Mihai Altian on kaggle.com. And here is the link for the data. Let's look at the data. So we have two folders, training and testing. So if you click on training, okay. So we have several folders here, multiple folders here. Uh, and for example, if you click on banana folder, we have several images for bananas, and each image has only one fruit, and that image was shot for this fruit from different angles, so all images are not same. uh, and if you notice that the file names are named randomly with the numbers, but the folder name indicates which fruit type it is. Uh, and we have exactly 103 folders, which means that we have 103 fruit types, but each folder has multiple images. For example, grape white 3 folder has 492 images of a grape white tree, and so on and so forth. And if you look at this folder, it has kiwi images, uh, 466 image files of kiwi. So my use case is to train my model by reading all these images, and consider the folder name as the category name, um, as our dependent variable, and identify the fruit that we have in the image and classify the image based on the fruit type, based on the fruit it contains in the image. So that's our use case. As you see that we have training folder, and same we have test folder for testing our model. uh, Here also we have 103 folders, which means that we have 103 fruit types images, and each folder has multiple images. Okay, in total we have around 71 images, or all images are of color, and we have 103 fruit types. So that's about our data set. Now let's look at the ADD document for our use case, and that is architectural design document. Okay, this is my ADD document for the Capstone project. And this is the overview diagram. I'm using Keras CNN uh, for identifying the, as you can see, as you already know, the objective is to identify the fruits in the provided images and classify the image based on the fruit type it contains. And I'm using a Keras CNN, and once the model has been trained and tested, and if a random image of the fruit has been fed into this network for layers, then this neural network should be able to identify the image and classify that image based on the fruit it contains. So it's a classical multi-classification use case. So I have two layers of convolutional neural networks, convolution 2D, maxpool 2D, and that's one layer, and We have another convolutional layer and one fully connected layer and one output layer, which will do the classification of for 103 fruit types. As we just saw that the data is available on Kaggle, and this is the link. And the data exploration, all the images are of fruits are of the same dimension, that is, I mean, same resolution. It is 100 by 100 and by 3. 3 indicates that these are all color images. And we have 70k plus fruits images available in order to train and test and validate our model. So all those images are split into 3 sets: training set, test set, and validation set. Training set contains around 50k plus images, and testing set contains around 17k images in order to test our model. Training set images are for training our model, and validation set is for randomly evaluating our model. Okay, validation set has very minimum number of images. Images are extracted from the link provided, and these images are already pre-processed, and so there is no need of a pre-processing of those images again, or a normalization of these images again. And we are not doing any feature selection in this use case. And as I already told you, we are using Keras CNN model, Keras convolution neural network, in order to identify the fruits in the images and classify that image based on the fruit type. And we are using loss function categorical cross entropy, since it is a multi-classification model, an optimizer add-on, and accuracy metrics. So once I trained my model, the accuracy is around 90% and the loss rate is 0.32. And after I tested the model, the accuracy is around 85%, which is pretty good. Now let's look at the actual code. Okay, I am importing all the Python libraries that were needed for this Capstone project. And here the first thing that I'm doing is, for initial exploration of a data, I defined a function in order to plot those images, few images from the given folder. So this function plot images accept 3 input variables: the path of the images, where path of the images, I mean the folder path, and the fruit name, and the number of images that this function will display. Okay, and in the next step I'm displaying the images from each path, from each input path that was provided. As you know already, as I already told you, that all the images are not same, and images of these fruits are taken from different angles. As you notice that, okay, these images are for strawberry, and some images are taken from the side, and some are taken from the top, and same with the pineapple and lemon. So our model should be intelligent enough to read the images provided, and no matter from which angle the image was shot, it should be able to identify the fruit in the image and classify that image based on the fruit type. and I'm using Keras image pre-processing methods in order to read all the images from every folder from 103 folders. This is the function that will helps us flow from directory, and this is the path where my images are. The training image sets are in this training folder. We have 103 folders of fruit types, and each folder has multiple images. I'm mentioning the image resolution and color and batch size and class mode. Ours is a categorical. Uh, so this function reads all the images from all the training images set folder and creates an object train generator. So it is able to find 53k plus images from 103 folders, and it automatically this function automatically identify that we have 103 fruit types or 103 classes. Okay, so we if an random image has been fed into the model, there is might be a chance that it belongs to one of the 103 fruit types or classes or categories. Okay, so just with few lines, we can realize that how much powerful the Keras is. With a few lines, it is able to read. Uh, it is able to read. It is able to read all these images uh, from each and every folder. Even the file names are some random numbers, but it is able to consider that okay, the file folder name itself is the category for category or image or fruit type for all the image files that contains within that folder. So with a few lines it is able to do that. So you can realize how much powerful the Keras is. So next uh, step, I'm defining my CNN neural network layers um, in a function called my model. Um, Convolution 2D layer max pool 2D convolution 2D max pool 2D, and this is the fully connected layer, and this is the final output layer, which has one or three categories or fruit types. I'm providing the input shape, which is 100 by 100 by 3, and here I'm compiling my um, model with the loss function, categorical cost entropy, and optimizer Adam and matrix accuracy. And once we look at the summary, we have around 6 million parameters that needs to be weighted. 6 million parameters whose optimum weights need to be found. And here fit our trained images object train generator that we have created here. Okay, it contains 53k images, so I'm fitting those images train image sets to the model, and I mentioned epochs has 25 times, and for each epoch we have 25 steps. Um, So as you can see that in the first epoch, the loss rate is 4.4 and accuracy is 0.05, and for each epoch the loss rate is kept reducing, and after 25 epochs we have 0.32 loss rate, and accuracy is 89%, which is very good. So once we trained our model, uh, the next step I'm just uh, printing the folder names and its one hot encoded number for each category. So here the category is pineapple mini, and the one hot uh, Keras is able to assign a number for each folder uh, that it read from. So say that okay, say that it read 78 folders, and the next folder is pineapple mini. So it assigned 79 number to that folder, and all the images that were read from that folder has category of 79. So uh, the images once the images has was fed into the neural network, it identify, I mean, it will convert those images into arrays, and do the convolution, filtering, max pooling, and do all that, and find out that the image uh, that was read from the image that was read from this folder belongs to this category. So uh, and the orange is of category 60. So these are all we can treat these numbers as one hat, we can as one hot encoded numbers. So Keras is doing that. This function that we saw here, train datagen, uh, uh, is able to even convert the category labels into a number. So it is taking care of that one hot encoding system too. It's not entirely an hot encoding. It's converting into an actual integer number. Okay. So I'm just printing out each folder name and its assigned integer number. So here, in order to, since we already trained our model and the accuracy is around 90%, I'm trying to evaluate our model by providing some random image, one or two images into the model. Here I mentioned the item directory path name as pineapple, and and I'm fetching the first 10 images in that folder. So folder name is pineapple. Since folder name is pineapple, all the images within that folder contains pineapple images. When we fetch first 10 images from that folder, all those images should be identified as pineapple. And once we run this code, it should be the image was displayed. This is the input message, and my model here should be able to predict, the model should be able to predict the image, I mean the fruit within that image. I mean, it should be able to understand the image within the fruit within that image, and identify what that image uh, uh, what type of classification that image belongs to. Here the identified fruit is pineapple, and index is 78. If you look at here, the pineapple here, okay. Um, when Keras image pre-processing read the images from the pineapple folder, it assigned a categorical value 78 for that pineapple folder, and all the images read from that folder, it considered it as pineapple. So this is what the number that what you're seeing here. So no matter how the image was shot or fed into the model, it is my model is able to correctly identify it as a pineapple. It correctly identified that it has a pineapple. So which is pretty good. So no matter how the image was shot and fed into the model, uh, it identified the correct categorical number, that is 78, which is nothing but pineapple. So all images are, these are first 10 images within that folder pineapple. So it is able to identify them as pineapple. All of them are correctly predicted. So that's pretty good. And since we have 17K images in the test folder, here we are testing our model with out of sample data to see how well the model is performing. So we generated, in the same way we generated a test generator object here, and then we fitted that test images set to our model, and here the accuracy is 86%. When we trained our model, the accuracy is around 90 89 90%, and when we tested our model with out of sample data, which means that data was never uh, uh, that mode, which means that data out of sample data is nothing but the data is new data for the model. So when we tested using our out of sample test data, the accuracy is 86%, which is pretty good. So we are I'm able to uh, achieve our objective here. My objective is to identify the fruit with an image, within a provided image, and classify that image based on the fruit type it contains. So it is able to do that accurately. So I guess we are able to achieve our objective here, and thank you for the uh, review. Thank you.